Covalent bonding in molecular compounds. So, first off, a molecule is a neutral group of atoms joined to form covalent bonds. And a diatomic molecule is a molecule that contains two atoms. So some examples of diatomic molecules would be chlorine, nitrogen, hydrogen. I'll give you some more. Fluorine, bromine, iodine, and oxygen. So these are the diatomic molecules. All right, so we have all the halogens, so fluorine, chlorine, bromine, iodine, and then nitrogen, oxygen, and hydrogen. So we see over here, we see a water molecule, an oxygen molecule, and a sucrose sugar molecule. So molecular compounds. So a molecular compound is a compound composed. Okay, should be a compound composed, so we'll cross that off. So a compound composed of molecules. So a chemical formula indicates the relative numbers of atoms of each kind in a chemical compound by using atomic symbols and numerical subscripts. A molecular formula is the chemical formula of a molecular compound that shows how many atoms of each element a substance contains. So we look here, so we have H2O, and we see this subscript tells us how many atoms of each element we have. Okay, the subscript to the right of the element symbol. So hydrogen would have 2 atoms, and oxygen would have 1. If there's no subscript there, it's understood as 1. Now, if you look at C4H10, we'd have 4 carbons and 10 hydrogens. Now, if we had something like this, say we had sodium phosphate. Now, this 3 NAs, excuse me. Now, this 2 must distribute to each term or element in the parentheses. So we'd have 2 phosphorus and 8 oxygen. We're going to multiply the subscript outside of parentheses by the subscript inside the parentheses. So 2 times 1 is 2. 2 times 4 is 8. Okay, so representing molecules. So there are a variety of diagrams and molecular models that can be used to show the arrangement of atoms in a molecule. So we see the ammonia molecule. Ammonia is NH3. So that could be shown in a molecular formula, a structural formula, space-filling molecular model, ball and stick molecular model, and a perspective drawing. So formation of a covalent bond. And actually, this is where we're going to stop. And this concludes our video.